Hey Math 20-3 and welcome to Chapter 3. This is going to be on surface area, volume, and capacity. Alright, let's get going. So first off, we're going to be dealing with surface area of prisms. Alright, so you guys have this in your guys' notebook too. You're going to want to keep track of this. If you want to, you can take this page out so you can have it handy while you're doing the other ones. Just make sure you don't lose it. So this is just going to be like a formula sheet type of thing for all the different shapes that we're going to do. All right. So I'll let you guys go ahead and look at these ones. There's just a few figuring out the surface area. So remember what surface area is though, is it's like this shaded area that I've got in here, right? So if we want to figure out the surface area of all these things, they have different formulas. So area for the first one is length times width. So that would just be 6.8 times 4.5. For a triangle, it's 1/2 base times height. And then area of a parallelogram is still just base times height. All right, let's go through some of these ones though. So it says for each picture, name the shape and calculate the area. So you probably know this shape, it's a circle. So you can go back to your formula sheet and see that a circle, the formula for that is area is equal to pi times r squared. So what I'm going to do on each one of these is write down the formula. So area is equal to pi times r squared. Now what I'm going to do is I'm going to work down and I'm going to fill in what I know. So I still don't know area, so I'll write down A is equal to pi is just 3.14, right? So you could write 3.14 at this point, or you could just write pi, whatever you like. And then we do know r, right? R in our circle stands for the radius. So the radius is the distance from the center of the circle to the outside of the circle. So that would be r. And that's the number that they give us. They gave us 44. So instead of r, I'm going to write in 44. And then it's going to be 44 squared. You don't have to put it in brackets like I did, but I just kind of, whenever I like replace like a letter with a number, I like to put it in brackets just to show that that's kind of what's being put in there. Okay, then what you do, grab your calculator, and you're going to go, okay, so you're going to go pi, so just make sure you can find the pi symbol on your calculator, and then times. So pi times, and then 44, and then you're going to have a button that looks like this, right? The squared button. And you can see I've got pi. They've given me like all the digits of pi. That's what that is all up there, right? Like a really long thing. And then 44 squared. And then that's not your answer. You still have to push equals. So that's going to be 6,000. So I'd write area is equal to 6,082.1. Let's just say 6,082 millimeters. And it's millimeters. And then our units here are going to be millimeters squared. Whenever we figure out the surface area of something, the units are going to be the same as what you were measuring in. So we were measuring in millimeters. So surface area is going to be the same thing, but it's going to be squared for your units. Okay, and then just circle or put a box around your answer, and that's it. All right, B. So we need to figure out what that kind of shape is. Let's go back to our formula sheet. Well, even though it doesn't necessarily look like this one, it really is kind of the same, right? It's just a triangle. And the formula for a triangle was A is equal to 1/2 base times height. So I'm going to write that down. So A is equal to 1/2 base times height. And what I'm going to do here to make it a little bit easier, well, let's just even leave it like that. So 1/2 base times height. Okay, so now even though the base in this case is, or sorry, the height in this case is like over here and up, that's still the height. So we still just need to use those two numbers. So to figure this one out, it's just going to be A is equal to 1/2. But instead of 1/2, it's going to be easier to put in your calculator if you write that as 0.5. So 0.5 times base is 9.3, and then height is 5.7. So the area, if you multiply all those things together, is going to be 26.5 meters squared, right? That's our units for surface area. So that's what the surface area of this thing was. Okay, next one. What kind of shape is that? Well, let's go back to our formula sheet. That kind of looks like this shape, doesn't it? A parallelogram. So parallelogram, that's actually just the same formula as for a rectangle. We just need to go base times height. So we can go back to here. So we'll say area is equal to base times height. Okay, so in this case, they gave us three numbers though. Which one's the base and which one's the height? Well, you can see that if we compare that to this one, this long thing from there to there, that's the base, right? That is this 14.8. It's just on its side is all. So that's that one. And then your height is going to be from there to there. We actually don't need this 6.9 at all to figure out the surface area. Okay, so just filling this in, we'd have A is equal to, the base is 14.8 centimeters. Or if you want to just leave the units out for now, that's fine. 14.8 times 5.3. So the area is equal to 78.4 centimeters. Okay, D, well, that's another triangle. So surface area of a triangle is just area is equal to 1/2 base times height. And this one's going to do a little bit different just to show you that you can. You also could have just wrote this as area is equal to base times height divided by 2. That's the same thing as 1/2 times those things, right? So in this one up here, we went 0.5 times those things, right? You get the same answer if you go 0.5 times base times height, or if you go base times height and then divide it by 2. It doesn't matter which way you do it. So whatever way you like better, if you like to write it like 0.5 instead, great. If you want to write it like this and then divide the base and the height by 2, great. It doesn't matter which one you do. Okay, so let's go area is equal to. Now the base of this one is going to be here, right? And the reason why I chose that as my base and not this one is because I don't know what the height is. If I choose 13 as my base, I don't know what the height is from like there to there, right? But I do have a height of 9 if I choose 16 as my base. So we don't need this 13 at all. All right, so we're going to go, the base is 16 times a height of 9 divided by 2. So that's going to be equal to 72 inches squared. Inches squared. Oh, and one thing I forgot in the one up above, this should have been centimeters squared. My bad. Okay. All right, moving on. Okay, so let's just keep going with this. I'm actually going to let you guys go ahead and solve each of these now. So go ahead and answer A, B, C, and D on your right now. Okay, moving on. So now what we're gonna do is we've got these shapes that don't kind of necessarily fit the ones on our formula sheet, right? Is this the one? So what we're gonna have to do is kind of break it up into parts. So you can see what they've done in this example is they've broken this into the area of this one, and then we're gonna add it to the area of this one, and then add it to the areas of that one, and then add to the area. Actually, sorry, just add to the area of this whole thing. We can just figure out that triangle in one step. Okay, so I'll let you guys look through that one, but let's go ahead and I'll walk through some of these with you. So yeah, that's just still the example there. All right, so let's figure out the area of, let's say, this one though. All right, so for this one, what we can do is we want to make this into two rectangles, right? So I'm going to draw a line from there to there. You also could have drawn a line from here to here. Wouldn't have mattered. You could do it either way, but let's just pick one. So I'll just do the original one I did there, this one. And now we got to figure out the area of this and the area of this one. All right, so let's figure out the area of the blue one first. So we'll say the area for that, the area for a rectangle is just base times height. So we'll say the area is going to be 6.5 times, I guess that'd be height, but height times base doesn't matter, times 5. So the area for that one is 32.5 inches squared. Okay, so that's going to be one of them. Now let's figure out the other area. So the area of this top one is still going to be base times height. But we don't really know what the base is automatically, do we? We don't know what the bottom is. It's not going to be 7 because it's only 7 from there to there. But it's 5 from here to here, right? Because it's 5 inches from there to there. It's the same thing. So if I just go 7 plus 5, I can tell that the bottom here is going to be 12 inches from there to there. So now I know the base of that one. So we'll just go area is equal to 12 times 8, which is 96 inches squared. Okay, and then all I gotta do is add those two numbers together. So we'll go 96 plus 32.5. Wow, brain's not working right now. 32.5 is equal to, what is it equal to? 128.5 inches squared. And then circle your answer. So that, yeah. Okay, so that's that one. The next one here now, we need to break this up again into some shapes here. So what I'm going to do is draw a line from there to there. And now we're going to have the area of this triangle and then the area of the rectangle. So the area, we'll call this area 1, the area of the rectangle. And this will be the second area, the blue one. Okay, so the area of the rectangle should be pretty straightforward. So we'll say area is equal to base times height. So area is equal to, well, just make sure that we don't use the 9.6 for our base though, because our rectangle only goes from there to there, right? And that distance for my base is going to be 7.8. So it's going to be 7.8 times 4.2. So that is going to be 32.8 that's meters squared. So that's our first one. Now we got to figure out what the area of this triangle is over here. So I can see that 4.2 is the distance from there to there. So that means that's also the distance from there to there, right? So I can say that this is 4.2 meters. And now I just need the height for my other part of my formula, from there to there. Well, how do we figure that out? Well, I know that the bottom here is 9.6, right? The whole thing from there to there. And I know that it's 7.8 from there to there. So if I subtract those two, what I should have left is the distance from there to there, or the height there. So I'm just going to go 9.6 minus 7.8, which is equal to 1.8. So I know my height here is going to be 1.8. That's what the height from there to there is going to be. Okay, so now my area for a triangle is 1/2 base times height. So the area is going to be equal to 0.5 times the base, we said was 4.2, times the height we just figured out was 1.8. So the area is going to be equal to 3.8 meters. Okay, last thing to do, we just need to add those together. So we'll say 32.8 plus, actually I'll even make these the right colors. So we'll say 32.8 plus 3.8 is equal to 36.6 meters squared. Okay. Okay, number 4. Show 4 different ways you could divide the figure below to calculate its area. Show all measurements. Choose one method to calculate the area. So ways we can divide this would really be, well, I could go like this and that, right? And then we could figure out the area of this one, and this one. Or you could break it up like this and like this, and now I can figure out the area of this one, and that one. I could break it up even to more parts and go that, and we could go like, the area of that one, the area of that one, and that one. Or we could do the same type of thing, but break this up even into parts, so like that and that. So there's lots of different ways you could break this all up, but in the end, you should end up getting the right surface area. So I'm going to let you guys go ahead and try this one now. Just remember that, yeah, so I'll even give you kind of the starting point here. So let's break it up into, that's a terrible line. That one, and maybe that one. Actually, you know what? I'm going to break it up into, I'm going to change it up a little bit. Let's do that. I just think that might be a little bit easier for you. Okay, so area is equal to base times height. So I'm going to say that's like area 1. Do you know the base and the height? So for the first one there, 4.6 times 3.6, right? That would give you the area for that one. And then the area for the next one here, for like down here, we're going to have to do a little bit of math. And not much. I guess it's not too much to ask you to do a little bit of math in math class, right? So what we got to do is just go, if we want to figure out what the distance from here to here is, our height, well, it's 6.2 for the whole thing, right? The whole length of that is 6.2. And if I took this 3.6 and subtracted it, subtracted that part, what I should have left is this. That would be your height for that part, right? So once you get that, so we've got our height there. So remember, area is equal to base times height. So you've got the height so far, so good there. We need the base. So right now, 8.8, that's going to be the distance from the whole thing, right? From there to there. But if I subtract, if I go 8.8 minus 1.8, I should be left with just the distance from there to there, right? So you guys then you'd have your base for both of those. And then finally, this last one is actually a little bit easier. So the last one, if you know your base is 1.8 and your height, you can figure out your height from somewhere else in this picture. That height should be the exact same as this height, right? So it's the same distance there. So then it's just that times that. Once you get those 3 areas all figured out, add them all together. So go ahead and answer that question now. Okay, so now we are moving on to kind of more complex shapes now. We're moving on to something called prisms. Whoop. So prisms are the things here below. These are called prisms. Bases are going to be the bottoms of them. So in this case, the base, let's say, of this one down here is going to be, that, and then the shape on the exact same shape that'd be on the bottom there. That would be the base of it. The lateral faces, those are the parts going up and down. So that's that. Your lateral face would be going up. Yeah, that's pretty much it. So that's what a prism is. So for this first one, It just says name the following prisms. So this is what's going to be called a right prism. And the reason why we call it a right prism is because I don't know if you remember like a right angle, or maybe you remember like a right triangle had like a 90-degree angle. That's what we call like a right prism. So it just means it's like straight up and down. So it's a right rectangular prism because it's a rectangle and it's like straight up and down. You can go 90 degrees there. B, this is a right hexagonal prism. And it's a hexagonal prism because it's a hexagon at the top. Right? So 6 sides is a hexagon. And it's a prism, or it's a right prism because it goes like straight up and down. You have a prism and then you have these sides that just go straight up. C, this is a right triangular prism. So we have a triangle as the base, and then again, it's like we've just like extended that triangle upward from there. So it's like a right angle. The face just goes away from that. And then D, this is what's called an oblique rectangular prism. And it's oblique, not right, because it doesn't go straight up. So we have a rectangle as the base, but it doesn't go from there. The faces don't go straight down from it. No, that wasn't even straight down. They don't go straight down from it. They go off on an angle. So it's not a right rectangular prism. It doesn't, yeah. So hopefully that makes sense. So we call that oblique if it like kind of like goes off on an angle from there. Okay, so name the following prisms. So remember, it's going to be the name of the base. So this one, it's going to be something to do with a triangle, right? And it's going straight down from it, so it's going to be right. So this is going to be a right. I'll have to write underneath here too. Triangular prism. Okay, so you can see this naming, right? So we say right if it's straight up and down. This one's kind of on an angle. I think it's straight up and down. I think it's just kind of like a bad picture. You could probably just as easily say this is an oblique, right, or triangular prism. It's just kind of hard to see if it's just kind of like on an angle and straight up and down, or if it's actually kind of going off to the side. I think I would take either answer there. B, well, that's going to be right again, right? So it's going to be a right rectangular prism. Okay, C, well, the face here, what's it called when you've got 5 faces? Or sorry, 5 sides, I should say. So 5 sides of that shape. Well, it's going to be a pentagon, right? And it's right because it's straight up and down. And they're all prisms. So it's just going to be a pentagonal right prism. D, we've got 4 faces, or 4 sides. But if we look back to our formula sheet, we have a name for a shape like that where both sides kind of go inward like that. It's called a trapezoid. So this is going to be a right. It's still right because it's actually no. I guess this one's more kind of oblique. It's kind of off on an angle. So you'd say this is an oblique trapezoidal prism. So that'd be the name of that one. Okay, and then this E, well, that's the same kind of shape that's on the stop sign, right? So that's going to be a octagonal, and it's right, so that's going to be a right octagonal prism. And then finally, we've got pretty much the same thing as B, so for F here, except it's not right, it's oblique. So we'd have a oblique rectangular prism. Oh, yeah, so so write those things in there. So I'll let you guys fill those in now. Okay. So now we're going to be dealing with something called nets. Don't worry, I'm not going to let you fall. We're dealing with nets. Yeah. Sorry, bad joke. So what a net is it's just a way of figuring out the surface area of a complex shape like this, where we got like a whole bunch of sides. So what we can do is we can like unwrap this shape, and if you unwrap that shape, it would look something like this, right? Where you've got the two ends of this thing. You can imagine like the face of this. If you like open that up, that would be, this over here. You could open up the other side if you like unfolded it down there, and that would be this. And then after that, you could unwrap these things. So I could like have like this and this kind of like come off. You could like unwrap it like it was a box that you're putting together, and you get all these different faces, right? So we could just figure the reason why we do that is because now once it's kind of like laid out like this, you can just figure out the surface area of all these shapes um, pretty easily, right? Once you have it kind of laid out like this, we just need to figure out the yeah. So that's pretty much the gist of this. So let's just kind of move on to an actual question here. Okay, so to start drawing this one out, I can see that this is 15 on the one side there, and then 5 and 5, right? So when I unpack this, it's like you're making a box like this. I'm going to have well, I'll even start with the rectangle that's in the bottom of this, right? So I'm just going to draw a rectangle. And that's going to be the very bottom. So that's going to be, I know this is going to be 15, and then this side of it, like the top of my rectangle there, is going to be 5, right? So now if I like unpacked this face and just kind of flipped it over, I could have it down here. So it'd be right there, right? And then if I went to the other side of the box, like kind of the back side of the box, then that would open up like this, right? If I opened it up, so we got like another one. And then the last one that we have to remember is the top of the box. So if you kind of flip the top of the box over, that would be like down here. So hopefully that kind of made sense to like unpack all those sides. And then the last thing we're going to do is we're going to like open up the two ends of the box. So remember, this was like our original bottom of the box, we said, and then we flip those ones out. And then if we flip those other two, it would look something like this, right? Okay, so now that you've got it set up like that, we've got the ends of this box, if I can erase that without erasing everything, we're 5 by 5, right? So 5 and 5. So now I just need to figure out the area of all these things. So if I figure out the area of the two ends first, let's say, they had an area of 5 times 5, right? Base times height. That's just for one of them. So the area of just this one, let's say, is going to be 25 inches squared. But I want the area for both of them, so I'm going to say times 2. So that's going to be 50. So the area for both of those things is going to be equal to 50 inches squared. Maybe put like a box around that because we know we're going to have to add that to our other ones after. Okay, and then now the other shapes here, they're all going to be 15 by 5, right? Because that was, that's still a height of 5. So I'm just going to go area is equal to 15 times 5. So that's going to be 75 inches squared. So what I just found there was the area of like just one of those big rectangles. So now there are 4 of them, right? They're all the same. They all ended up being the same there. So I'm just going to multiply those by 4. So I'm going to say times 4. So if you go 75 times 4, it's 300. So we're going to have an area equal to 300 inches squared. We're just going to go now, we'll just go 300 inches squared plus 50 inches squared is going to be equal to 350 inches squared. And that would be your final answer there. So that would be the surface area of all of those sides. All right. So I'll help you kind of draw the net for this one. So what I would do is open up the faces, that side and then the other side. So we're going to have I'm going to put it like on a different angle here. We're going to have like those triangles like that. And then that bottom base, the other triangle on the other side. And then we're going to have two of these, right? Okay, and that's it. And then you just need to figure out the surface area for those things. The other bit of info that I'm going to give you that's going to make this probably a lot easier too is that the height of this triangle, we're going to call that 2.6. That's how high it actually is. So that'll make things a lot easier. So the height here is going to be 2.6. Okay, so I'll let you guys go ahead and finish that question. So just figure out your surface area of all of them, add them all together. So answer that now. Okay, number 7 says, Ralph says that diagram A is the net of a right octagonal prism. Manon disagrees. She says that diagram B is the correct net of a right octagonal prism. Who is correct? Justify your answer. So I'll let you guys go ahead and answer that one now. Okay, example 5. So this one's really just another example of a net. The only difference is that we've got like 3 different sides now, so it's going to look a little different. It's going to be just a little bit more complex. So you can look through that one. Okay, so for 8 though, just one thing I want to add, just make sure you kind of know this. This doesn't really look like a right angle triangle, but that little box there means that it is. So in our picture, that should be, that triangle up top. So that'll make it easier, so that you know that the 4 in this case is going to be the base of your triangle, and the 3 is going to be your height. So that should make things quite a bit simpler there. And I'm actually going to let you guys skip C, so you can cross that one off. Okay, so example 6 now. You could draw this out as a net if you liked, but you don't really need to. So you can just go through and make sure that you get all of the different surfaces of this thing and add them all together. You can see that this is probably this might take a while. Something you'll probably want to do is like break that up into 2. And just you have to make sure that you get all of those different surface areas. So they kind of walk you through how to do that on this one, so I won't go through that. But I am going to get you guys to do these ones. So just like I said, it might take a bit of paper to do these ones. They're going to be longer than you think. You just need to figure out the surface area just one by one. So figure out the surface area of that side. So in that case, that would just be 2 times 0.5, right? But there's 4 of them, so you could go that times 4 to figure out that one, the other side, and the other side. You could figure out the top by just going 0.5 times 0.5. You can figure out the surface area of these ones, so that, and pretty much multiply that by 4 to get all those ones around the outside, right? That one and the 2 ones that are kind of in the back. And then you can figure out the surface area of the bottom. Oh, that was terrible. I'll redo that. And the bottom down there. By just going 1.5 times 1.5. And then the only kind of tricky one here is going to be this. It's going to be the top of this one. So how do you figure that out? Well, if you figured out the surface area of the bottom, 1.5 times 1.5, that's the same as the surface area of the top if this shape wasn't sitting on top of it, right? So if you could figure that out. And then all you got to do is take the surface area of this, right, the top, because that's the same as this down here, and subtract it. So if you figured out the surface area of the whole thing, right, all of that, and then subtracted the surface area that was down, maybe I'll make that purple or something, this surface area, you'd have what was left. So then you just add all those things together and that should be it. So I'll let you guys go ahead and do that one now. Okay, number 10. You need to be able to work your way through this one, so you'd have to break this into parts, and you can figure out the surface area of that, and just make sure you get all those faces. Don't forget about the ones that you can't see, right? Because there's the face on the bottom, there's the face on like that side, and there's also the faces on the back side of this one. So go ahead and do that now. Okay, so now for the practice your new skills part. I'll let you guys. Well, actually, never mind. Let's just do this one. So I'm going to let you guys go ahead and answer these on your own now. So number 1 says, sketch the nets of the prisms and use them to determine their surface areas. So go ahead and answer 1A now. Okay, here's another one. Sketch the net and then answer the question. So go ahead and answer 1B now. Number 2, however you say that, Hoeth, is building a feed trough for his cattle. The trough is to be triangular with a length of 12 feet, a height of 1.5 feet, and a width of 4 feet. How much wood is required to build it? So really, what's the surface area is kind of what they're saying all the way around the outside. So what we need to do is, break it up into, you can either break it up into a net if you like drawing it like that, or you can just figure out what the surface area of each one of those things is and add them all together. So go ahead and answer number 2 now. Okay, number 3. Aaron is going to construct a fish tank that is 1.2 meters long, 0.6 meters wide, and 0.4 meters high. How much glass will he need to make it? Note, there will be no glass on the top. So what I would recommend is drawing a 3-dimensional object that has these dimensions. So go ahead and answer 3 now. Okay, 4. A grain elevator is a tower containing a bucket elevator which scoops up grain and deposits it into a storage facility. Calculate the surface area of the grain elevator shown here. Assume that the front face of the grain elevator is vertically symmetrical. So that just means that, like, if you drew a line straight down between that thing, that everything on this side would be exactly the same on that side, is all that symmetrical thing meant. Okay, so again, you just need to make sure that you get all of those different surfaces. One thing we didn't talk much about, though, was trapezoids. So figuring out the surface area of that one. So remember the trapezoid, if you go all the way back to your formula sheet, that was this one. So if you need a little help putting that one into your formula, just call me over, call your teacher over. So it just be area is equal to, instead of 1 over 2, you could write that as 0.5, and then whatever your base is plus whatever your A value is, the bottom, plus whatever your B value is, the top, and then just multiplied by the height. So in this case, if we go all the way to wherever we are, I can see that my A value, well, let's even just do it. So I'll say the area of that one is going to be equal to 0.5, and then it was A plus B, right? So that's going to just be 32, right? Because this is 32. It's the same as the one on the bottom, so that's my bottom. And then my A value is 12, because that's got to be the same as that, right? So 32 plus 12, and then times my height. So my height of that trapezoid is 12. So the only thing that I'd recommend doing, though, first is put this part into your calculator first and then rewrite it. And the reason why I say that is because your order of operations in your calculator might get kind of messed up if you don't do that. So what I'd do is go 32 plus 12, which is 44, right? So I'd rewrite this whole thing as just 0.5 times, this was 44, and then times 12. And just multiply those things across. So that'd be the area of that shaded part for your trapezoid. Okay, other than that, they're all just rectangles and triangles that we've done a lot with. So I'll get you guys to go ahead and answer number 4 now. Okay, that was a long video, but it was good. Okay, so that's going to be the end for that one, and I'll see you guys in the next video.